Right now, it is my pleasure to welcome Augie Fackler and Nathaniel Manista. Please give them a warm round of applause.
Hi. Hi, good afternoon. Thank you for coming. This is my friend Augie. He is a contributor to Mercurial and various Python libraries.
This is my friend Nathaniel. He's the tech lead of Melange, the Summer of Code web application that also runs Google Code and has contributed to Pylint.
How many of you test your software? Good, good. How many of you test your software from the perspective of a user? So if you're writing a web app, you have tests that drive a browser.
Okay. Now, how many of you document your software in terms of stating what people can actually explicitly depend on about your behavior? Yes, good. Now, how many of you have had an angry mob come after you because you made some change to your software, it didn't change any of your guarantees, and all of your tests kept passing, but they were still angry because something had changed?
Okay, we've all been there, and we've all had that problem, and we want to expand on these topics today to give you some better tools to have a better conversation when that situation comes up. And what we're going to be talking about is behavioral envelopes for software. Now, these aren't going to be like a physical envelope metaphor. It's not going to be like putting network packets in some larger envelope. We are thinking in terms of flight envelopes for aircraft.
So this is the flight envelope of a F-104A Starfighter airplane. This particular envelope talks about the behavior of the aircraft as it relates between its airspeed and its altitude, and there's some extra information on here about g-forces that's kind of hard to understand. But if you're above those curved lines and still inside the white space on the chart, your plane flies and you're having a pretty good time. If you're below those curved lines, your plane isn't going fast enough to fly, and if you're in the red space, your plane is falling apart.
Now, I found this compelling because it's a very simple metaphor, right? It takes all of a given space along certain dimensions, and it divides it into what is allowed and what's not allowed. And I wanted to know, can we do this for software? For software systems, we find dimensions along which some use of the software is allowed and some is disallowed. Whether it looks like this, we don't quite know what the dimensions are yet, but can we talk about our software this way in terms of envelopes?
And so we think that we can, and in fact, we have some examples. The math package in Python has this square root function, and it actually has a very well-defined set of inputs. Right? You can give it any number that's greater than or equal to 0, and anything less than 0 is invalid. It'll give you a value error. At another level of abstraction, if you've bought a video game, the web store or the box will have some descriptions of what the requirements for your system are, right? How much RAM you have to have, CPU speed you need, things like that. One of my favorites runs in 4 gigs of RAM, but I have to close my web browser because I only have 4 gigs, because otherwise the performance is really terrible because I'm at the bottom end of acceptable performance there.
Another example is an HTTP server, and there are a bunch of different ways we can look at HTTP servers. There are a bunch of different things we can call HTTP servers. So here's a Python class, right? And it's a Python object, and it's an HTTP server, and it has an input. And the input must be of type HTTP request. And if we pass it a string, that is unwarranted use of the system. The system is not specified that way. So if we look at this system's behavioral input, there is, in the space of all possible Python values, there's an allowance for objects of type HTTP request, and everything else is disallowed.
At another level of abstraction, an HTTP server is a service you're talking to over the network. So you connect to it, you send it some sequence of bytes. If that's a valid input, it works. If it's some forbidden input, maybe you're just sending it random garbage, it will tell you that you sent it an error. That might look something like this, right? The plane in this case is every possible sequence of bytes, and the red dots are sort of a crude representation of things that are going to be invalid.
Now, sometimes when we talk about an HTTP server, we're talking about something like this. And even though it's a physical system, it still supports a notion of disallowed input.
Right? This is a disallowed input for this server, right? Some joker decided to hook a Cat5 Ethernet cable up to a wall socket and called it the ether killer. So you can let the magic smoke out of your Ethernet card and it'll stop working.
But we can still talk about the system's input in the same terms, right? From -1 to +1 volts is supported input, and everything else is disallowed. We've drawn it in 2 dimensions here, but because there are 8 wires in the Ethernet cable, it's actually kind of an octo hypercube.
Now, we both have some amount of background in physics, and one of the things we do in physics a lot is sort of look at a system from both sides and try and apply similar principles. So we're going to go through the looking glass and start talking about the outputs, because we've spent a lot of time thinking about inputs to a system.
So when we talk about the outputs of a system and output envelopes, we're not talking about systems that have deterministic evaluations, right? This is a system that always evaluates to the exact same value. In fact, that's what the utility of this expression is. And here's another one. If this didn't always produce exactly the same value, it wouldn't be nearly as useful to us. But here's a system that doesn't produce exactly the same value every time. But it doesn't produce any arbitrary value either.
Right? It's going to give you a value between 0 and 1. But the promise is actually that it will give you some random value. That's the whole point. There are other more complicated systems that have definitions kind of like this as well. This is a software package we discovered writing this talk that is a database which will give you less accurate results the quicker you want the results. So one of the inputs you give to the system is how fast you need a response, and it'll give you less accurate data the less time you give it, but it still guarantees some value.
Systems that operate in the presence of adversarial contact, such as those that are proprietary in some way, or something like games that are dealing with cheaters, will often have inexact specified system behaviors, right? Because they don't want to give too much away. They simply want to specify the bare minimum that they possibly can and leave room for a lot of different implementation details. So we've talked about input envelopes, and similarly there are output envelopes. And we're going to describe now that a system's behavioral envelope is the sum of those things and any other incidental behaviors in between, like side effects. And so this is kind of like a wormhole through multiple dimensions, that there's some input domain with dimensions of its own, and a system will translate into another universe into some output domain with some other dimensions.
So now that we've defined what an envelope is, we want to say that you should be stating your system's behavioral envelope. Preferably, the only communication that your clients should need to be able to make use of your system should be this description of what behaviors you're guaranteeing and not guaranteeing. You're probably already doing some part of this, right? You specify valid inputs, you specify the range of outputs, maybe you talk about what parts of your system are thread safe.
Now, when you specify your envelope, it guarantees that you will have thought about it, which will put you head and shoulders above many of your colleagues and peers who haven't done that.
So we see 3 tools that are the most readily accessible for defining these envelopes. The first one is a type system. That's a Java example because it's a stronger type system I imagine many of you have encountered. There's machine check constraints, right? The tests in that documentation. And then the documentation itself is also very important because there's some things you just can't fit in a type system.
So digging deeper into type systems, here's the same function in 2 different languages, right? We have Python on top and we have Haskell on the bottom. In Python, the function exists, but there's no type-rich information about it. We can't query it for what its types are. It doesn't communicate what its types are. The Haskell version has a type annotation along with it, and scripts and machine assistants can come along and can say to programmers using it, can say, hey, you've made a mistake here, you've made a type error here. Also, new users of that function can come along and they can look at it, and without reading a word of prose documentation, they can see, okay, this is a system in which inputs and outputs are related a certain way. And in particular, they can see that the input type of the first argument of the function must match the component type of the second argument of the function. And so its behavioral input kind of looks like this, infinitely far along the dimensions of the first and second arguments to the function, but only valid along the line at which the component type of the second argument matches the input type of the first argument.
Now, tests generally look something like this. And the tests are valuable because they're sort of these fence posts, right? The type system traces out this nice, broad, continuous boundary for you. The tests are sort of suggestive of a boundary. We'll come back to that later. But these tests, they're useful, but they're not necessarily what you might want to show to somebody else. So you might also write tests that look more like this.
Right. So when we're saying you should use tests to define your envelope, This is a very easy test for you to tell a client about, for you to use as part of your specification.
And then documentation lets you sort of fill in the gaps where you don't have other tools, right? Very few type systems let you annotate whether or not something is thread safe. You can probably do it in Haskell because their type system, I believe, is Turing complete, but you can't do that usefully in Java or Python. So these systems don't just stand in isolation. They're very complementary, and that reminds us of our childhoods.
Right. So this reminds us of defining space another way, which is when we were kids, like we'd go over to the aunt's house, and we'd want to go out in the giant backyard to play, and the grown-ups would want to keep an eye on us. And they'd tell us things like, okay, I want to be able to see you when you play, so don't cross that line into the woods and stay between the two trees on either side. And this is curious because it's defining a space using a combination of continuous lines and distinct points along some other dimension. This is kind of the way that type systems and test specifications play together, is that type systems draw continuous contours through some space and separate out all values of one type from all values of another type, whereas test conditions specify specific points with specific values of individual types.
Right.
But you can still use them in combination to define some region of some space.
So coming back to software, here's a different HTTP server. Instead of taking a request object that's already done a whole bunch of work, this takes a string in and emits a string out. And so from the type system's perspective, the input looks kind of like this. In the space of all possible objects, there's this ellipse that we'll assert represents all strings that can come in. Now, we can start writing tests that that we reject things that are invalid, and then add in more fence posts that are basically things that are valid. And you can sort of see this boundary within the domain of strings, that some strings are valid and some aren't, but it's not described in this nice concrete way where there's a hard and fast line.
So when you've received guidance that says you should author your test conditions near the boundaries of what your software supports, the reason for that is that your tests are in part defining the boundaries of what your software system supports.
And then documentation and types work together very well too. So this is a screenshot of some Java doc just because it presents better than some of the other documentation systems. But you notice there's a bunch of types in this slide that the programmer didn't put there. And in Python's generated documentation, you'll still see like the names of the function arguments as they're specified in the code. These things play together very well too.
How many of you have ever read software that contains this? Written software that contains this? All right, this is a legal disclaimer that says, legally, there is no reason for you to believe that this software is any good for anything. But when we write software, and specifically when we want to persuade clients or customers to use that software, we'd like them to believe that our software accomplishes some goal. We'd like them to see that our software works. And the way that we can do that, the best way to do that, is with a demonstration of it, with a real live exercise of code. That comes from tests. Tests are real live exercises of code. So this is another argument saying you should ship your tests as part of the definition of your software.
And you should not just have tests that are, unit tests, they're a bunch of code that's kind of unpleasant to read. If it makes sense, if it's part of what your clients should really be reading as part of your documentation, you should have in your documentation machine-checked examples that people can read from and understand how your system operates in a more fluid way that they can trust because, of course, that itself is machine-checked and verified to still work.
So where we are is your system has an input envelope and an output envelope that comprises its behavioral envelope, and we're saying you should use that types, tests, and documentation to specify that. Now, are some envelopes better than others?
Yes. In particular, we feel the smallest envelope you can usefully provide to your users, or library users, end users, is the best one, right? The fewest promises you can make today, but still have a useful package is what you should be aiming for. And fewer promises makes everyone happier, because
fewer promises make everyone happier because fewer promises reserves future growth. If your system is going to be long-lived, and if your system is not going to break backwards compatibility, then your envelope must never recede. And so if your envelope starts small, you're reserving space to grow. If your envelope starts large, you're going to have a lot of promises to keep as time goes by.
So we've got some examples of envelopes that have sort of been ill-defined, right? There at least is an envelope defined, but we're not happy with it. And so the first one I'm going to pick on is HTTP-lib. HTTP-lib is actually a pretty decent HTTP library. If you're doing the normal HTTP-ish things, you're not going to have any problems other than the API being a little bit wacky. But my beef with HTTP-lib is right in the docstring for the module, it has this enormous state machine that actually bleeds off the end of the slide. And it's not important that you can see the whole state machine. It's important that it's there, and that after that state machine in the documentation, it has this wonderful sentence, which states that I'm not going to enforce this state machine, even though it's what I assert that I'm going to go through, so that if you're a sophisticated client, you can abuse my internal implementation details to do something clever like implement request pipelining. Now that sounds awesome, but it's actually terrible because it means you can't go in and fix defects in the implementation of HTTP-lib because you've documented all of this internal behavior as part of the things that your clients can depend on. And in fact, there are things that I would try and fix in HTTP-lib that just aren't feasible because of the documented internal behavior.
Now, we've talked about envelopes for systems that are directly callable, such as functions. It turns out that classes have envelopes as well. And in particular, the input envelope of a class is the set of functionality that is available to call on that class. Java's object class is an example of a place where the input envelope was gotten wrong. They were deciding what is the set of methods that should be callable on all Java objects. And they mistakenly made it too wide, and they included these two methods in that set. And it turns out that these were specified in such a way that they couldn't always fulfill their goals, and they wound up being useless and meaningless, and they're warts on the language, and no one really uses them at all anymore.
For a concrete example, finalize is like dunder-del in Python, right? It's the thing that gets run when your object is being cleaned up by the garbage collector. The problem is that the semantics of the garbage collector are such that you have no guarantee your object will ever actually be cleaned up. And as such, there's no guarantee that your finalize will ever run. And so if you have some expensive resource you thought you wanted to clean up, you can't depend on this to actually do it. So we have some positive examples, things that actually make us happy as well. We're not just cranky today.
I really admire what was done with the original HTTP protocol. It started off with these 15 response codes that you see here. And 15 response codes is an enumerated finite set. And most of the time that we have an enumerated finite set, we say, OK, I'm going to number them 0 through 14, and I'm done. But what was done with the original protocol here was they broke it up, they spread it across a range of 1,000 integers, and they used the hundreds digit to communicate the general class of the response code. So 200 is everything's good, 300 is I'm sending you over there, 400 is you made a mistake, and 500 is I made a mistake. This left a lot of room for future growth that they reserved. And in particular, in the original protocol specification, they reserved what you should do when you get a response that you don't understand.
Now, the other positive example is the futures package in Python 3, which has a backport to Python 2. And what a future is, if you haven't played with the library, it's a way to schedule some piece of work to be performed in the future, and then you pass it to this executor class, which will run it when resources are available, however it's configured. And when you actually need the result of that future, you can block on it. So you can fire off a bunch of requests in parallel or something and then block on them all at the end. What's great about this is the definition of an executor is sufficiently narrow that it already ships with 2 implementations that basically have the same guarantees. The process pool executor requires that your arguments be pickleable, but other than that, they function identically, and it's possible to envision something that would use, say, Stackless's micro threads instead of heavyweight threads.
Now, one of the things that happens when you start talking about envelopes is that you find that they're necessarily different than the code that they constrain. So how many of you think that this statement is thread safe? How many of you think that this statement is not thread safe? How many of you think that this statement is thread safe if my key is already present in the dictionary?
Okay. So it happens in the implementation details that this is thread safe. But the reason this comes up is because we had a discussion internally that led to a lot of frustration, because some people were saying, oh, this is thread safe, I've read the source code, and other people that read the language specification and said, there's no guarantee that it actually has to be thread safe. So we're asserting that source code is not the best documentation, that the best documentation is the definition of the envelope, the things you can actually depend on.
So when you're first starting to program, everything's exact, everything's precise. And programming starts to feel like wiring a circuit together. You're assembling some aggregate behavior that will be precise and deterministic out of precise and deterministic subparts.
But
when you
instead,
start engineering with envelopes, it feels a lot more like plumbing in an aggregate flow system.
Right, things kind of fit together loosely. They don't always fit precisely the way you expect them to, that sort of thing. So to summarize, you should be providing the smallest possible but very well-defined envelope, and you should try your very best to only rely on the stated envelope others provide.
Thank you.
Thank you.
Questions? Yes, in the red.
Hi there. Thanks. That was a great talk and something I think a lot more programmers need to know about. I just wanted to make one comment on one of your slides about tests. One thing we've done on the Twisted project that has helped us use tests as one thing that we've done on the Twisted project that has helped us define tests as part of an envelope is to ban test docstrings that begin test that or ensure that, or the word correctly particularly is not allowed in tests. Everything is just a declarative statement about what that system does in a particular situation or context or with certain inputs. So for example, not test that a certain page displays correctly, but say when the root page of the website is requested, a 200 error code is, or a 200 status code is returned and the title is displayed, or something much more specific. And forcing everyone to think about that has actually made our tests much more specific and also separate. So because if you have the one test, which is test that it loads correctly, every time you expand that envelope of correctness, that test just gets bigger and bigger and more squirrely.
Mm-hmm. Yes,
Yes,
I agree. And I like the fact that we don't talk about correctness when we talk about defining envelopes. It's up to you to define what's correct or what's supported for your system and to communicate that through types, through tests, and through documentation. And not to worry about necessarily like some abstract or objective or universal notion of correctness. There's just the correctness of whether a system behaves as you wish it to behave or if it doesn't behave as you wish it to behave. Let's go to this side.
So first of all, thanks. That was really great. I'm wondering if you've looked into whether there exists anything, or if it's feasible for such a thing to exist that actually would define this envelope as a thing rather than a loosely associated collection of docs and tests and types. Is there some other language out there that does that? Could Python do that?
I think it would be very challenging given how loose the type system in Python tends to be. I imagine there's a research language out there that somebody is either working on or has done that tries this, but I'm not familiar with one.
I'm not remotely familiar with anything, and the challenge feels large, given that we're talking about the sum of what type systems can do, what dynamic constraints as exercised by tests can do, and what's done in documentation because it doesn't fit into the other two systems. So it feels like a huge problem.
So I was wondering, what sort of tools do you currently use to try and do this in your job right now?
So my system's a little peculiar because I work on version control software. So most of my stuff that you actually are aware exists is inside Mercurial. And Mercurial's test suite actually is sort of this, I guess you'd call it literate programming, right? It looks like an interactive shell transcript, and then it's split up by the test runner and executed. That's certainly worth looking at. For higher level functions, I try to use doctest. I haven't written anything complicated enough. I've felt the need to reach for Sphinx, but I've heard that it's pretty good.
In Python, I use PyLint for static analysis, which is the closest to a type system with which I use. Unit test and a few other testing frameworks, not as much for testing. And I also have lint check my documentation to make sure that argument descriptions are present, return value descriptions are present, because in a lot of code that I've seen, especially old code that I've taken over and had to maintain going forward, the inconsistencies in the behavioral envelope or the problems in the behavioral envelope sneak by when the doc strings of the code are absent or missing pieces. And so I find that, because I'm my own best friend, I'm eager to forgive myself most, and I'm a poor critic of myself. If I can outsource that criticism to an automated system which will then tell you, hey, you're underspecified in this way, it helps me prevent it helps prevent me from fooling myself, which is a perennial problem of mine. Back on the left.
So you mentioned taking over projects, inheriting projects that aren't well defined, that don't have a good envelope. Do you have any other recommendations on taking a situation where the source essentially is the envelope and getting to a place where it's better defined in doc strings and whatnot?
It's a slow incremental process that's very painful, in my experience. I don't know if you have anything better than that to say.
I know of a huge system at Google that was taken over that was underspecified, and the first thing the lead engineer did on it was define a test suite for it. And they went forward, and over the course of several months, as this test suite expanded, they would make changes to the code, and that would break someone, and then that someone would complain, and they would say, okay, we're glad you're here. We're glad you're vocal. We're sorry you're crying out for our blood, but we're going to take your use case and build it into the test suite so that this doesn't happen again.
Yeah.
What do you think about using assert statements to make envelopes more explicit?
I use assert statements for that all the time. Some people don't like them as well. I dither on whether assert is the right tool or raising an explicit exception is the right tool. But I like them.
Yeah, I agree. They're fine modulo my overall philosophy on assert statements.
Which is?
They scare me because they can be turned off in certain contexts. Yeah.
Okay. Thanks.
Hi. Unfortunately, I still have to write a lot of C++ code that we comment using Doxygen.
Okay.
And one of the things that I really like about Doxygen is that there are actually some directives for documenting preconditions and postconditions, which seems to me like it fits really closely with what you're trying to express.
It does.
As far as I know, Python documentation tools don't provide anything for that. I use Sphinx all the time, and I haven't seen that there. Any comments on that?
I don't happen to know any.
Yeah, the documentation tools I've come across in Python, I've never seen that as a feature. I didn't know about that feature of Doxygen. It sounds great. I wouldn't mind having something like that in Python.
So thinking about it for a moment, I'll say that perhaps something that the lack of a formal system for that has done to the style in which I code is that it has pressured me, and I've moved to this new practice of ensuring that the type system itself ensures the satisfaction of my preconditions. So for example, instead of taking an argument of type string, as we saw in one of those HTTP server examples, where the string could parse as an HTTP request or it might not, I favor more creation of objects such as the one that the HTTP server that took an HTTP request object, so that by the time the server is invoked, you already know that the precondition for its invocation has been met by the type of the object passed to it. And that plays nicely with a whole lot of other things, such as loose coupling and minimal specification and so forth. So I would say, look and see if you can go in that direction. One more?
Just actually a follow-up of the last question. We actually do have a facility in context lib and the with statement built into Python now that effectively can enforce pre and post conditions as invariants. And I can't say that honestly that I've used it a lot for that purpose, but it is actually a rather elegant way to express, invariance that you expect, around a function call or around another block of code.
Okay, and you're saying that's in the standard library context lib module?
Yeah, just the with statement in general.
All right.
But, it's easy to build context with the context lib.
Yeah. On the right side again?
Yeah, I just wanted to mention NumPy had about 4 or 5 years ago a huge improvement in their documentation, and what they did was to introduce a NumPy documentation standard that explicitly required that you have to specify the inputs, what type they are, and what the returns are, including all the types. And the NumPy doc package is automatically converting then all this information into Sphinx documentation. So this was a huge improvement in getting standardized documentation in most of the scientific Python SciPy stack.
Okay.
And I forgot the second one.
Okay. Thank you.
Thank you.
And thank you all for coming.